All right, ladies and gentlemen, this is Mrs. G. We are going to continue today with some of the basic equations of solving equations. We're still only talking about generally doing one step to come to our answer, but now we're going to talk about dealing with multiplication and division. So feel free to take a moment and put that title on your notes and come back. When you're back, be aware that when we solve equations, there's three kind of conceptual ideas that are really important to understand, and it's going to be even more important to understand as we move into more difficult and complex equations. Okay, one of the ways we can visualize an equation is kind of like a scale or a balance, where here's the equal sign. Okay, we have one side of our equation equaling the other side, of our equation. Okay, and when you think about this as a metaphor for an equation, it's really a good way to understand some of the rules. Okay, if this scale is perfectly balanced, this side weighs the same as that side, well, think about it. If you were to, take one of these little green cubes off, then your scale, well, that's gonna go up. Okay, because it's gonna weigh less. How could you make it balance out again? Well, you could take this one off of the other side, and then it would balance and make an equal statement if you're thinking about an equation, or, as a metaphor, the balance would be, balanced out or the same on both sides. So that's a really great way to think about how to work with equations. And so I think you already have these in your notes, but see if you can remember them before I click here. So remember, we have to cancel each operation by doing its opposite. Okay, if you want to make something mathematically kind of not necessarily disappear, but cancel out to make zero, you want to look at opposite operations. Last time we talked about the opposite of addition is subtraction. The opposite of subtraction is addition. Okay, we also need to understand that an equation is like a scale, and anything that is done to one side of the equation must be done exactly the same on the other side of the equation. Okay, and then we always are trying to get the variable alone. Okay, some fancy math terms would be called isolate the variable. Okay, because once the variable is alone and you're all the way done with solving, you would get x equals some sort of number, and you would have solved that equation. Okay, so let's actually go about doing some problems here. Okay, so we're solving equations of multiplication or division. Okay, yesterday we learned the opposite of addition is subtraction, and the opposite of subtraction is addition. We have kind of this idea of opposite operations. To undo a multiplication, we can divide. Okay, and to undo a division, we can multiply. Okay, let me show you that in kind of just a real basic example problem down here. So 4 times 6 is 24. If I want to undo this multiplication of 6, I say, okay, well, 24 divided by 6 will take me back to what I started with of 4. Okay, so just like addition and subtraction kind of undo one another. Okay, if I add 5 today, but then take away $5 from you tomorrow, well, now we're back at 0. We're even. Okay, if I start with, 7 students, and tomorrow I have 3 times as many, and I have 21, I can get back to those 7 students by, I take my group and I divide it into 3 pieces, which brings me back to where I started from. Okay, here are some example problems that are going to kind of visually show you what these problems might look like, and there's a few new things. Okay, remember that 3y means 3 times y, but we don't write that x in there anymore. We don't really write even a dot in this case. If you're doing 3 times y, we just say 3y. Okay, and the way that we're going to write division, okay, the way that you guys write this actually speaks to what's happening, so it is important. It doesn't make sense. Okay, we're going to divide both sides by 3, but that's really not the best way to write it. Instead, let's write it as a fraction divide by 3. Well, why is that so important, Miss G? Well, when you do that, you're actually understanding why they cancel out. Why? Because 3 over 3, the fraction, is always the same as 1. Okay, you can think about this like division, 3 divided by 3, or you can think about, any pizza that you cut into 3 pieces, but then you take all 3 of them, is always just one full pizza. 3 over 3 is 1, 10 over 10 is 1, 100 over 100 always is going to simplify to 1. Okay, so what's really happening is 3 over 3, they both really kind of divide out to make 1. 3 over 3 simplifies to 1 over 1, and 1 over 1 is just 1 or 1y, so you're left with just y. Okay, y equals, everyone, 8. It is 24 divided by 3 makes 8. Okay? When you see this type of problem here, well, now this is really a division problem. But again, we're starting to kind of go away from using this symbol and to really understand that z over 4 is the same as z divided by 4. Okay, so how are we going to do this? You're going to do the opposite operation. If you see a division, to undo that, we multiply. The way that we write that, you can put a little dot. Please don't put an x, because we don't use x to mean times anymore. Put a dot and put a 4 here. Why is that kind of showing what's happening? Well, if you think about 4 as 4 over 1, now you're thinking about this makes sense if you think about cross-canceling. Okay, 4 on the top and a 4 on the bottom really simplify to just make 1. 1 over 1 is 1. 1z is really the same as just z. So if we multiply by 4 on both sides, we'll be left with just a z all by itself, which is what you want. Remember, you're trying to isolate the variable. So over here I times by 4, so here I write times by 4. Okay, we don't have to write 4 over 1 because this number itself isn't a fraction, but if it were, it would be a good idea, if this was 12 over 5, you would just write times 4 over 1, and then you can multiply those fractions. That's not as hard as we're going to get, unless you're choosing kind of the red and black level. There might be some fraction stuff on there. But for now, just understand, we're multiplying on both sides by 4. So z is equal to 48. Okay, I'm going to clean this up just a little bit so that when you copy that in your notes, you can see what it is I'm looking for as far as showing you work. Okay, so write on both sides that you're multiplying by 4 because the original problem is division, so you're going to do the opposite, which is multiplication. Now remember, you can check these. Okay, maybe I haven't told you this yet, but the way that you can check is take your original problem, in my case, 3y equals 24. Take the answer that you got and put it into the equation. Okay, this is why we practiced evaluating, because this is how we use that idea of substitution or evaluate when we solve equations. So 3 times 8 equals 24. Yes or no? Well, yeah, of course, 3 times 8 is 24. Fairly easy to see visually. You could probably do that mentally. But once we start getting longer equations, you will not be able to do it mentally, and it's a really nice tool to have, okay? For your perfectionists out there, you can always check your answer and know if it's right before you hand it in to Ms. G on a test. Okay, so to check, we take our original problem, z over 4 equals 12. Instead of writing the letter z, you take it out and you put in your answer, 48. Is 48 divided by 4 equal to 12? You betcha. So you know you got it right. Okay, I'm going to show you some more examples. If you want to stop and write those down, that's great. But we do have some more, which will test a bit more of some fractions with negative numbers and maybe even some decimals over here. So this problem here, number 1, what it says is n divided by 7 equals 6. A lot of you can do this mentally, but understand if you can do it mentally, maybe you want to try some of the harder level questions, the black level homework, where maybe you won't be able to because there's some fractions and decimals. So the problem has a division in it, so I need to do the opposite, which is multiply. So what I'm going to do on both sides is times by 7. So multiply by 7. These 7s cancel because it's like simplifying a 7 on the top with a 7 on the bottom, and you get n equals 42. Please don't be lazy about showing your work. You only have to write this and this. It's not that much, ladies and gentlemen. Okay, but people who show their work consistently get right answers on tests and quizzes. Okay, number 2. Well, what's happening here? Negative 5 next to a? Well, you should be saying to yourself, that's negative 5 times a. Okay, the opposite of multiply is to divide. We write that by simply writing a little bar as divide by negative 5 on both sides. We write it that way because then you can really visually see why these cancel. It's like simplifying a fraction. The same on the top as on the bottom means you're really just going to get 1. Okay, negative 5 over negative 5 is just 1a or just a. On this side here, we divide. Okay, 5 going into 55, well, that's going to be 11. And if you love to hate, you're a hater. So negative 11 on that one. Number 3 is an interesting one, which really kind of speaks to this idea of instead of writing divide by 6, okay, write it as a fraction. It makes this problem actually much easier to deal with. If we divide by 6 on both sides, you can see these 6's cancel. 6 over 6 is just 1 over 1, or 1y. Okay, yay, I got y alone. That was my goal. I get y equals 20 over 6. Well, that doesn't actually go in evenly, so all you really have to do is think about this like a fraction you can simplify. Okay, you can leave your answer in terms of a fraction. You don't have to do 20 divided by 6 and get some decimal answer. Okay, you can if you want, but you certainly don't have to. You could just simplify 20 and 6. Let's divide them both by 2, I hope you were saying. So therefore, y is equal to 10 over 3. And you can stop there. If you really feel the need, you could make it into a mixed number, but you don't have to. And then the next one here, number 4. What happens when we have a negative here? Well, it's still x divided by negative 7. So the opposite of divide is going to be multiply. The opposite of division is multiplication. So we write dot negative 7. And we need to multiply by negative 7, not 7. Okay, some of you might say, well, do the opposite. Doesn't that make a plus? Well, no. You're already dealing with the fact that there's a division in the problem, and you're multiplying to do the opposite. Okay, don't also change somehow the symbol on the 7. Okay, maybe I can make sense of that by saying, well, you want x alone. If you hate to hate, okay, you hate to hate, you're going to get a positive number. You're going to get a lover, right? So that makes a positive 1x, which is what you want. Okay, so if you see a negative 7 down here, you also have to multiply by negative 7. And then on the other side, obviously, we are going to do the same thing. Multiply by negative 7. So therefore, x is equal to negative 63. Okay, I'll clean this up a little bit. Multiply by negative 7. Okay, these cancel each other out, basically, because negative 7 over negative 7 is just 1s. And then really, a positive 1x is the same as just writing x. So we don't really need that coefficient of 1. Okay, so hopefully with these example problems, you're getting an idea for how this works. Remember, you could always check by saying, all right, 42 divided by 7 equals 6, question mark? Well, if it does, that's a true statement. You know your answer's right. All right, negative 5 times negative 11 is positive 55, maybe? Well, is that true? If it is, then you know you got it right. This one might be a little bit trickier, but I can walk you through that if you're interested. Basically, 6 over 1 here times y of 10 over 3 should give you 20. Oh, is that true? This is actually much easier than you might expect. Okay, don't freak out when you see a fraction. You can do this. We cross cancel here, making a 1 and a 2. Okay, well, I only have 1s on the bottom. So 2 times 10 is 20. Oh, yeah, it is. So that's really great. You can check your work. Okay, and then number 4, to check that one, you would just do negative 63 over negative 7 equals positive 9, maybe? Well, if it does, you know you got it right. Okay, so that's the idea of solving with multiplication and division. Still just one-step problems. If you're feeling like these are a bit easy, we can practice a bit with fractions. All right, if you want a bit more of a challenge, feel free to listen up. If you're feeling like you just want to start with the blue level, you can go ahead and stop now. But the red level and the black level, you're going to have a bunch of fractions involved, and that's how I want to challenge you guys a bit to see if you understand really how numbers work. So if you're interested in a bit of extra extension with fractions, listen up here. Basically, let's start with the first one. We can think about 1/3 times x equals 8 as the following. You could think about this like 1/3 times x over 1. So it's really 1x over 3. And in this case, it's really the same as just x over 3 equals 8. Okay, if you think about 1 times x is just 1x, and 1x is just x. This one, is a lot easier than you really might think. 1/3 x is really the same as x divided by 3. And this one we just multiply by 3. So x is equal to 24. All right, what about this one here? 5/9 times v equals 35. Okay, you want to get rid of this fraction in front. Well, if it was just 5v equals 35, what would you do? You would divide on both sides by 5. It's basically the same idea. Let's divide by 5/9. Well, it looks a little bit crazy. It looks a little bit messy. I have a fraction on top of another fraction. Well, ask yourself this question. To divide by 5/9 is the same, KFC, as multiplying by 9/5. We talked about that last unit. We talked about dealing with division of fractions. Keep the first, well, I guess we don't. Division can change to multiplication if you flip your second fraction. So, instead of writing this kind of weird looking fraction on top of another fraction, well, instead of dividing by 5/9, let's multiply by 9/5 times by 9/5. Okay, what's interesting, and hopefully you're seeing why this cancels out this part here with the variable, is, well, what happens when you cross cancel? 9 on the top, 9 on the bottom, make 1 and 1. 5 on the top, 5 on the bottom, make 1 and 1. 1v is really all I'm left with. 1 times 1 is 1, 1 times 1 is 1, and 1v is the same as just regular old v. So I have succeeded in getting the variable alone. Now on this side, I'm actually just going to multiply those two fractions. It's not as hard as you might think. Again, you're smart enough to deal with fractions. Don't flip out because you see a fraction. Cross cancel a bit here. Divide both of those numbers by 5. They have a common factor of 5. So this becomes a 1. This becomes a 7. 7 times 9 is 63. 1 times 1 is 1. So basically, v is equal to just plain old 63. Okay, we got a nice whole number in the end. And then this last one here illustrates an interesting question, okay? If you want a bit more of an extension, this one is really kind of fun. There is another fun little trick you can do to get rid of all the fractions in an equation problem. Okay, look at the denominators of 2 and 3 and ask yourself, what is the least common multiple? What is the least common multiple of 2 and 3? Well, 2 and 3 are fairly small numbers, so their least common multiple is simply going to be 6. Okay, so this is kind of fun. Okay, look for the LCM, and then multiply by that LCM on both sides. Okay, you might think, Miss G, this seems crazy. Well, how is that going to help me? Okay, remember, I can do whatever I want to an equation as long as I do it equally to both sides. So I'm going to multiply by 6 on both sides. And you might be thinking, well, how is that really going to help me? How am I going to get a simpler problem? Well, let's watch. Okay, following this idea of you can do whatever you want to both sides. I'm sorry, you can do whatever you want to an equation as long as you do it equally to both sides. Watch this. So I multiply by that LCM of 6. And I think about cross-canceling. So therefore, the 3 and the 6 become a 1 and a 2 on the right side of the equation. The 2 and the 6 become a 1 and a 3 on the left side of the equation. So look what I have remaining. I have 3 times 5, which is 15. I have 1 times 1, which is 1. On the right side, I have 2 times 4y, which is 8y. And I also have a 1 times 1. Well, 15 over 1, 8 over 1. I really don't need this part, guys. I'm sorry, 8y over 1. 8y over 1 is just 8y. 15 over 1 is just 15. Okay, again, don't freak out because you got fractions. Divide both sides by 8 because that's what will help you isolate the y, getting the y alone. Okay, you see a multiplication, so divide. Those cancel. Y is equal to, okay, if this isn't going evenly, you can simply leave it as an improper fraction. That's perfectly fine. Y is equal to 15 over 8. Okay, and as long as you can't simplify those anymore, you're done. Okay, 8 and 15 don't really have any common factors, so that's the answer. Okay, so here's a quick, or maybe not so quick, but here's a bit of an extension if you're interested in working on the red and the black level, dealing with fractions. Okay, I don't want you guys to kind of freak out when you see fractions. So feel free, you're all done. If you want to go back through your notes and listen to anything again, you can, but you are ready to start practicing. We have 3 levels. We have blue, red, and black. All right, enjoy. I'll see you later. This is G.